Hello friends. Welcome to our channel. Today we will talk about the working principle of transformer. A transformer is an electrical device that transfers electrical energy from one circuit to another through electromagnetic induction. It is used to either step up or step down the voltage of an alternating current, AC, power supply. Transformers are used in a wide range of applications, from power generation and transmission to electronic devices such as chargers, adapters, and inverters. The working principle of a transformer is based on Faraday's law of electromagnetic induction. According to this law, whenever a conductor is placed in a changing magnetic field, an electromotive force, EMF, is induced in the conductor. The magnitude of the induced EMF is proportional to the rate of change of the magnetic field. A transformer consists of two coils of wire, known as the primary winding and the secondary winding, which are wrapped around a common iron core. The primary winding is connected to an AC power supply, while the secondary winding is connected to the load. When an AC voltage is applied to the primary winding, it generates a changing magnetic field that induces an EMF in the secondary winding. The magnitude of the induced EMF depends on the ratio of the number of turns in the secondary winding to the number of turns in the primary winding, which is known as the turns ratio. If the number of turns in the secondary winding is greater than the number of turns in the primary winding, the transformer is known as a step-up transformer, because it steps up the voltage of the AC power supply. Conversely, if the number of turns in the secondary winding is less than the number of turns in the primary winding, the transformer is known as a step-down transformer, because it steps down the voltage of the AC power supply. The voltage ratio of a transformer is given by the equation V2/V1 equals N2/N1, where V1 is the voltage applied to the primary winding, V2 is the voltage induced in the secondary winding, N1 is the number of turns in the primary winding, and N2 is the number of turns in the secondary winding. The current in the secondary winding is determined by the load connected to it, which can be either resistive, inductive, or capacitive. The power transferred from the primary winding to the secondary winding is given by the equation P equals V1 I1 equals V2 I2, where I1 is the current in the primary winding, I2 is the current in the secondary winding, and P is the power transferred. Transformers are highly efficient devices, with efficiencies typically ranging from 95% to 99%. The efficiency of a transformer is determined by the losses that occur in the transformer, which can be divided into two categories: copper losses and core losses. Copper losses occur due to the resistance of the wire in the windings, and are proportional to the square of the current. Core losses occur due to the magnetic properties of the iron core, and are divided into two types: hysteresis losses and eddy current losses. Hysteresis losses occur due to the reversal of the magnetic field in the core, which causes the iron to heat up and lose energy. Eddy current losses occur due to the circulating currents that are induced in the core by the changing magnetic field, which also cause the iron to heat up and lose energy. To reduce these losses, transformers are designed with high-quality materials and precise engineering. The core is made of laminated sheets of high-grade silicon steel, which reduces eddy current losses. The windings are made of high-quality copper wire, which reduces copper losses. Transformers may also be cooled by air or oil to dissipate heat generated by losses. Thank you for watching. Don't forget to like, comment and share.